Today's notes are on operations with radicals. Today we're going to focus on I can add and subtract radicals. We're going to talk about the steps needed to add / subtract radicals. The first step, you have to simplify the radicals. The second step is you have to make sure that both the index and radicand are the same. So we're just going to do some examples of ones that you can add and subtract versus ones that you can't. And if we can, we'll go ahead and solve those through. All right, we're going to start off with example 1A. We're going to start with a really easy one. If I have 4 cube roots of 9 plus 2 cube roots of 9, then I will be able to do the operation because they both have a 3 for their index. Let me find my word index. So the index is the same. And then the radicand, which is underneath, is the same as well. Okay. Now, the whole point of this is that if these two are the same, all we have to do is act like this is an X. And we're just literally going to add together this front number. So I'm going to give this another color. 4 and 2. So this is one of like a basic one. 4 plus 2 is 6. So if it was subtraction, we would just subtract the things in orange. Let me highlight it in orange so you know where that came from. And then this back part's going to stay the same. We don't do any adding or subtracting. It's just like an X, like a variable. There, and there's our answer. Okay? So this one is yes, you can add / subtract because both have an index of 3 and a radicand of 9. All right, the next one, I'm going to give you an example, like a really obvious one. So if we have 1B, 3, the 5th root of 4, minus 2, the 3rd root of 4. All right, so let's talk about it. The radicand is the same. Okay, so if we're just looking at the radicands, and this is why on your EOC you need to make sure that you pay attention because they'll sometimes do trick questions like this. The radicands are the same, but our index is not the same. So one is 5 and one is 3. And we're going to say no because the index isn't the same. All right, we're going to do 2 more examples. One where we have to simplify. And then I think we're good from there. All right, everybody got that one? 1c 5 to the cubed root of 27 minus 2 to the square root of 4. Now, if we're looking at this, if I forget the simplify step, I might easily say that you cannot simplify this one. But if I look closer, 27 is equal to 9 times 3, and then 3 times 3. So I do have 3 3s for this one to come out. So this really turns into 5 times 3, which is 15. And then same thing, if I were to break down 4, it's 2 times 2. And so again, that can come out. Ooh, I did it right here. 2 times 2, so the 2 can come out. Oh, let me not erase that. Y'all, these are erasable pens. They're the coolest thing in the world. All right, so 2 times 2 is this one, which is 4. And 15 minus 4 is 11. Make sure that you are simplifying, because sometimes when you simplify, this one's simplified into whole numbers. But sometimes when you simplify, and you could put this one in your Desmos calculator and it will pop out this 11. But let's